Just to clarify, I didn't come all the way from Guatemala. But I'm from Guatemala. So my name is Jepser Bernardino. I'm a front-end engineer from Guatemala. And 3 years ago, I moved from Guatemala to Barcelona. And then I started working at Typeform. Typeform, at Typeform, we have a platform that let users to create forms like the one that you see here. The main idea is to start asking people in a more conversational way and stop interrogating as common forms do. If you want to try it, it's free, so you can go to typeform.com. OK, I finished my sales pitch. And today we're going to talk about the journey of a new interface. I realized in the last 2 days that this title doesn't say a lot. So to clarify a little bit what to expect, we are going to talk about how we created an embeddable app. Sorry, I have a typo there. An embeddable React app. All of this started approximately 1.5 years ago, when I was developer at the marketing team. We have these, what we call big pieces, which are articles in our blog that are heavy on content and need somehow special UI or special functionality. At that moment, we have an article about conversational UI. And chatbots were a thing. So we thought, what could be our shot? How a more conversational UI could be. After some iterations, we ended up with this proposal. So you scroll. At some point, you see questions popping up. You answer the question. Let's wait. And you see the next question. It's a really simple concept, where we have been seeing a lot of chatbot-like interfaces. But there was a plot twist. This is the final article. So you see that there's content on top, then the conversation, the interface, we call it conversation, and then more content. In this article, we embed, I think, 14 of them. And we thought, yeah, that's too much. But then we found out that by adding these kind of little blocks of information, of contextual information, help us to have more engagement with people. And also, we were getting better data from them, because it was contextual information. And we got a lot of traction, more than we thought. And our stakeholders say, hey, we like it. Let's build it. And that's when I moved from the marketing team to the new team called the exploration team. The idea was to kill Typeform. So our first challenge was to make from the concept that we had a product, an MVP, to be honest with you. So the first thing that we wanted to do is to create an easy-to-embed app. When I say that, it's because the conversations in the article were meant to work on the article. And we wanted to spread the word to the world. Also, we needed to base our conversations with Typeform's API. First, it has its own domain language, so it wasn't compatible at all. Then it should feel part of the content, as you see before. Even if it was an MVP, every decision that we make as engineers or as designers or as a product should lead us to a final product. And because of the previous experience, we knew that we need to somehow make all the siblings, let's say all the embeds, communicate between each other. And also the parent, let's say where I embed the application. The concept had simple animations. But the new concept that we were working on, or we wanted to work, needed more complicated or more complex animations. So we needed to handle orchestrating in there. As I told you before, it should feel part of the content. So customizing the embed was a must. When I say customizing, is that we wanted to mimic, as person-to-person conversations are, that I can ask for the same information in different ways, depending on if it's a friend, if it's somebody that I don't know, or the context. And we wanted to experiment on opening the black box. If you have used Typeform before with the current render, you will see that it's kind of a black box. And the only way to communicate with the embed is by unsubmission event. So we want to explore to open it more. So OK, let's just start. Just drink some water. Let's just start talking about what's an embeddable app in the first place. So an embeddable app, it's an app inside another app, kind of appception. And this parent app could be a WordPress site, could be another React app, could be a Vue app, could be whatever app. A common approach is to have an embedded script, which should be the minimal amount of code in order to run the actual application, which we will call just app script for example reasons. With the embedded script, we will need to have a snippet. The snippet will have a token. This token will be where I want to mount the application and which configuration I want to send to it. In this case, ours was really simple, was just a div with CUI embed class. And then we will pass all the configuration by data attributes. In this case, we are passing the UID, which is the form. And then we are going to, well, just put the script. We use async attribute because we didn't know where the user will put the script, so we didn't want to interfere on the normal loading times or loader sequential. So let's start talking about the architecture. So we have been talking about the embed script, the application, but then we need some tooling. We need a customizer, or that's how we call it. It's an application that will let our users to change colors and avatars and everything, and generate the code. But also we needed a BFF. The BFF stands for backend for frontend, so we needed to handle feature support because we didn't support everything, handling submissions, and also caching. But today we're going to talk about the embed and the app, which are the main things. While designing the application, the first thing we wanted to do is, hey, let's see how people could use it, the use cases. First, it could be just an embed. The black border box is the embed. Or there could be several of them, 1, 2, 3, 100. Or what if I just want to send the conversation to a friend? So it could be a full screen application. Once we knew that, we also knew that we are 25 front-end engineers at Typeform, so we have certain agreements, and React is part of our stack. Styles are managed by style components. And in case we needed to use some state management, Redux was the tool. So there's no brainer there. We failed in the first attempt. But we learned a lot. So the first attempt, just picture this. We have what we call the app shell, which will be the application. And the application will mount in the selected DOM element that we saw in the snippet, an iframe. And if we see how it will work, it will just simply as I have the embedded script will load the application will start, the application will mount, or we create an iframe into the selected DOM element. And the iframe will contain the DOM elements, but all the logic, all the styles, and communication will be managed by the app shell. Sorry, I put app script, but it's app shell. And to do that, we use React portals. React portals, I will try to remember how the documentation is. It says, first-class way to interact in a React tree that doesn't necessarily belong to the same DOM tree, something like that. So what does that mean? OK, let's imagine that we have a modal window. We have an application, a full React app, and then we have a modal window. With React portals, we are allowed not to move the modal window outside the div we mounted the application. So they don't belong in the DOM tree in the same level. But for React, it does. And the API, it's something like this. The interface for that is really simple. So when we create a portal, we say, OK, the first argument, I will put everything I want of React inside a container. That will be the DOM element. Let's see how we implemented it. This is not the real code. You just put some key stuff. On iframe load, I put it just as a placeholder so we know where iframe head and iframe body comes from. And part of the render function, it's this iframe. This iframe has two responsibilities. The first one will be setting a style sheet manager. This comes from style components. And the way style manager works is that it allows us to say, hey, I need these styles to be in here. And that's why we set target to be the iframe head. And secondly, we created two portals. The first one was for the head, so we were able to manage the head. And the second one was the children in the body. So the actual application will be set. And magically, everything worked. But when we were testing it into a React app, so we have our React app and put it into another React app, it broke. Then we find out that style components is a singleton, or at least it was when we tried it. And it will crash either the application, the parent application, or our application undeterministic. So then we say, OK, we have a limited time to work on this, and we need to solve it. And we have been working before with Emotion.js, which is another CSS in JS library. And they almost have the same API. Plus, they have instances. So we say, OK, let's change the way we resolve packages on Webpack, and then we just can switch it and test it if it works. And it worked. But when testing it with Mozilla, with Firefox, we needed to force an update. Because when we were setting the iframe head, it didn't exist for Firefox. We didn't dig there, but probably we could fix it. But we were limited on time. So we say, OK, we're going to do as big companies do. And that's when the last attempt, the third attempt came. And it was as simple as this. I have my embedded script that will just load an iframe into the selected DOM element. And the iframe will be the application itself. Sounds kind of boring, but that's the way it works. And it worked. Instead of having the app shell, we will have just the embedded script. We just mount two iframes. And you can see these patterns when you add a YouTube video in an iframe, or a Facebook post, or a Twitter card, and so on. And it worked because it was a shell. So because it was a shell, we needed to figure out how do we communicate between windows. I said to you before that we needed somehow to be aware of the parent and the other children. So because they are a shell, there's no to-go way to do it. After discussing, we said, you know what? We're going to go with what we know. Oh, sorry, I missed this. So why, in the first place, we want to be able to communicate? Well, we need to know when the application initializes. Not only when the iframe loads, but when actually initialized, or when we want to initialize the application. And we will see in a second. Managing customization was a little bit different before, because we had React in the outside. We could just set a new template provider, theme provider from style components. Instead, we needed to do something else. Also, we needed to manage what we call dynamic height, and you will see it. And finally, as I told you, we wanted to open the application, so we needed to have somehow a way to say, hey, I did this, or I did that. So InApp Events. Let's picture this. So I scroll. I see a loading screen, a welcome screen, and then the actual conversation starts. Again, it was too fast, probably. OK, so how do we manage this? Well, PostMessage. PostMessage has two flavors. First, I think, is web workers, and second one is for window. We're going to talk about for the window. The way PostMessage works is that, let's say we have two windows. It could be what I call parent window, and it could be a pop-up. Or it could be the iframe, as our case. The iframe, in this case, will emit an event, and then the other window will subscribe to it. And that's how it worked. And I could just turn around as well, so we could have a bi-directional communication. So PostMessage is just something like this. So the first thing we said is where I want to send the message. Then the first argument of PostMessage will be what I want to say. who sent it. And the third one, we didn't use it, but it's just for transferable objects. I didn't think what's about that, but we didn't use it. So how we implemented it? Well, we wanted to do something like reducer. So we basically did an action, create a function that will receive an action and a payload. And we will send it to our parent because we know that we are going to be embedded in somewhere. So we are going to send this to the parent. And we're going to stringify the object and send it. The asterisk, because since we don't know where are we going to be embedded, we don't have any restriction on it. And the way we use it is just by setting, OK, I have an action called resize frame, and I send the payload with a new height. From the other side, the parent will add a listener to the message event, which is the PostMessage name of the event. And we will try to parse the JSON, and then we are going to check if the data action exists, and the payload exists, and if the action exists in our list of actions. Then we're going to call the function, and we'd add which frame call it. So we know which of our children call this action. And the way we create the actions is really simple. So we just have the action name, and we'll send the frame to know who called me, and the height in this case, or when initialized. Because of the design that we had, we didn't want to go to a round trip to get the actual application to show the loading screen. Instead, we set the loading screen into the actual embedded script. So we just could know if the request is being delayed, show the welcome screen. Sorry, the loading screen. So let's talk about in-app events. We wanted to let a developer know when the application initialized, when we replied something. So if I ask, hey, what's your name? My name is Jepser. So we will receive this Jepser outside of the application. And also when you submitted the whole thing. So we needed to, well, the way we did it was by wrapping the PostMessage event and just create an EaseUI action event. We will send the name and the detail. And the other side, we have the actions. And the way we are going to do it is really simple. We just create a custom event that is a native feature from the browser, as you can see in the bottom. And then we are going to dispatch this event with from the frame, the parent node. Why the parent node? Because we already knew when we mounted the application that we will remove everything else that is not the application. So we're kind of certain that that will work. And to know or to hook into the actual actions, you just have to add a listener to the actual div, the DOM element that you mounted the application, and you will look something like this. So you will listen to, in this case, CUI reply, and then you will get all the payload of data in the event detail property. That's all from communication between windows. Another tricky thing was animation. How do we orchestrate the animations? So let's see another conversation. So we have different field types, an open question, then we have multiple choice, then we have opinion and scale, which is a number. You see that changed in the right. Then we have a picture choice. It seems simple, but each one of the elements have changed the UI in different ways. First, how do we validate the input field? How do we change the placeholders, the input type? In mobile, we have different keyboards, so each one of them have different keyboards, and we needed to know when to change it. And as well, as you can see in the last question, the picture choice pumps up the UI more than a normal multiple choice question. You will see in there, so normal. If the number field there, and then just whoop. So this kind of orchestration, it's called staggered animations. Staggered animations is basically a collection of elements that follows animation naturally. It's not this, but this. Previously, in the concept, all the animations were kind of simple, so we managed to do it with timeout or CSS transition delays. But this wasn't the case, so we needed to find something that was more event-driven. And also, we wanted the animations to be composable. When I say composable is that we have, let's say, 4 animations in a row. if we put a fifth one, it should be natural or easy to do in a declarative way. Or if I put it a new animation in between, or I change animation, it should expand naturally. So no CSS transition. We already knew that we didn't want to use CSS transitions because we're too imperative. And we researched a couple of more libraries, and we found 3 that we liked. First one is React Motion. The second one is React Spring, but none of them convinced us. But then we found React Pose. I have to say something against React Pose. Even if it's almost half of the size, twice of the size of React Spring, and 4 times, a little bit more than 4 times React Motion, the benefits that we got from the library reached the footprint that this library had. So we decided to go with it, and I will show you why. The first thing we liked is the syntax. If you have been working with style components before, this should be familiar for you. So you have a React Pose component, then you select the tag that you want to render, and then you set the animation properties. In this case, I just put enter or exit. But it could be hidden, visible, short, tall, whatever it's more descriptive for you. And the way you select the transition between one or the other will be by setting the name of the animation into the prop and the post props. So let's say I wanted to play with style components as well. I just have to wrap the animated component into style component. And because they work together, the reference is already forwarded to React Pose that needs the ref to in order to work. And I just changed the name to style and animated component. Instead, if we want to use motion, we are going to set the configuration of the component where I use the component. So you see that I set a new motion component, and then I set the default styles. And then I will set where and how I want to animate it. Then I, by render props, interpolate into the styles, and then I will animate this div. Let's see it with React Spring. I will see from and to properties, and then I will send from which animation to what animation I want to do, and the same thing. Render props, and then I just interpolate into the styles. I have to say that with the syntax that React Pose has, we could make our designer's lives better, because he likes to tweak art styles. And also, he liked it to tweak the animations, because he was the picky one. So by separating the configuration of the components where the implementation detail is, was easy for him, because he didn't have this overhead of seeing all of this content and be freaking out if he could break something. So that helped us as well. Second thing that we liked, it was animation interface. So let's see an example, finally. So we have an enter and an exit property, animation property, and it's really simple. I will transform in the y-axis, and then I will change as well the opacity. It will show something like this. It's really simple, no? But what if we want to be more granular about the way I change the y animation, the y transformation? Well, React Pose has this transition property, which is the special, that it will set for you how, or you will set how you want to animate the library certain property. In this case, I'm saying, hey, you know what? Can you do a spring with a stiffness of 100? And then React Pose say, yeah, OK, I could do it. And it just do it. Because React Pose is just a wrapper of Pop Motion, which is a JS library for animations, you can actually use it with it. And you can do more complex animations. You can do twins. You can do physics animations, easing functions really easily. But this is not practical. I mean, this is a good for example, but it's not practical. What if I want to go for a more natural way to show these 2 boxes? Well, we have been talking about staggering animations. And with React Pose, it just becomes trivial. I'm saying that I will put a delay, and I'm passing the I property, could be index, into that component. And if I have 2 components, I have mapped them. The first one will be an index 0, and the second will be an index 1. So I know that the second one will have a delay. So it just comes with the same animation, and then it staggers. This is cool for me, because it's really easy. And it's cooler if you see how React Motion does it. So you will see that first, well, we will go. So I have two elements. I have to describe that I have two elements in default styles, because I'm putting two animations. Then I will interpolate and map them to know how I will animate them. And it will then, in render props, interpolate the styles, and then map over the style, over the elements. This, for me, is more difficult to read than this thing. And if we see as well React Spring, it's a little bit more simpler. But still, I'm stick with from and to. With React Pose, I can change. Yeah, React Pose, I can change the name of the animations of whatever I want. And 13, composable. So let's see another example. We have an animated parent, which will animate in the x-axis. And then I have the animated child, which will be the same animation as before. In this case, what I will do is that in the animated parent, I will set which pose I want to transition from or to. And you see in the bottom that I just set the two animated children as before. It's animated. So the parent will come from the left, and then the children will come with an opacity. Still kind of nice, but it's not practical. So we have been talking about staggering again, and it becomes trivial as well, because I just have to set two properties. The first one is stagger children, which is 300, so it will have the same effect as before. And I will say as well, hey children, please wait 300 milliseconds until I finish. So the parent will finish the animation, and 300 milliseconds after, they will trigger the children animations. So it will look something like this. So with this code, we already can have a nice sidebar animation. So we have been talking about Post, but Post also have something called PostGrip, which unlocks more flexibility. All of the things that we have been talking, it's animating a transition between two states. But what if I want to animate when the component mounts or the component unmounts? Well, PostGrip that does for you. You still can have the exit and enter properties, which are the convention. And then plus that, we will have an interface that will let us know when a group of animations ended, finished on rest, by using on rest property in a PostGrip. So let's say I have these messages that are popping up. In order to know when I have to show or change the input type in my interface, I would just use on rest, because I know when all the group finish animating, I say, oh, change me the type of the field. But if I want to be more granular, I can say, you know what, I want to see when each one of the children finish their animation. And I can use on post complete. I know that you shouldn't use our functions inside the render function, but it's just to show there is a function. So this is the example as before. You see that the placeholder changed at the right moment. You see that anything collide. And we have tested it with really, really, really long forms. So it's still good. So it's not, it uses everything of good practices with animations underneath the library, which is nice. And let's see one last example. If you see in the bottom, there is a expand property, which has a max height of 1,000. Why we needed it? Well, we found out that there is people that have this anti-pattern of our conversation manifesto. We try the bubbles to be as shorter as possible, so you have less content. But there are conversations that have these kind of bubbles. So we wanted to truncate the message, because then it just broke our animation strategy. And by doing this, by just setting then the transition from from enter to expand by clicking read more, we could also do something like this, which was nice. So it was really simple to implement it. So I think that's all. There are 2 more slides, or 3. First thing is that once we were creating the application, we tried to use as much as native possible. So instead of hooking into the scroll event, we were using intersection observer that I think somebody said before, which is really performant. As well, we use fetch instead of access, for example. Even if access has a better API, we thought that using fetch is good enough for us. Also, I couldn't find anything related to custom events, like another solution, but still, custom events is something that you could use for your applications as well, PostMessage. And finally, in the performance talk, they talk about this. And I was thinking to remove it, my slide, but yeah, I think it's useful. So every time we investigate into a library that we wanted to use, we use bundle phobia to know which could be the footprint of this application, how this will affect us. Also, in each PR, we use bundle size to know how this new functionality or new refactor or fix will affect our final bundle. In our case, we had 17 kilobytes an embed. I'm not proud of it. Could be less. But also, as well, the application was 120 kilobytes as a bundle, which was below our threshold. And finally, if I want to be more granular and check how each one of the libraries affect my bundle, I can use Webpack Visualizer. If you want to see more about or learn more about the project, you can visit labs.typeform.com/UI. You can ask requests. It's free as well. So yeah, I think that's all.